to talk about, so this was internal energy. Now, next I want to talk about heat capacity. Heat capacity. And since we're talking about ideal gases, what was heat capacity, guys? Excellent. U is a function of T and V. Okay, so now it is a function of more than one variable. So that means in order to figure out the internal energies that are with respect to T and V both, what do I have to do? Delta U will now become partial U over partial T when the volume is kept constant, dt, plus partial U over partial V when the temperature is kept constant, dV. Okay, so put this in a box. So there are two ways we can do this. No, two things. Constant volume. Leave lots of room, guys. Constant pressure. This is going to be called CP, and this is going to be called CV. So what was our first law again?
Delta
Equals Q plus W. Okay, so we're going to start here again. Okay, so suppose we have N moles of gas, of an ideal gas. And number two, we are talking about quasi-static processes. What does that mean? Processes so slow that they reach equilibrium at all points. Okay. So for our first case as constant volume, what will happen to my first law? It's a constant volume. Somebody said? Who said? Good. Delta V equals 0. So what will my equation reduce down to? Delta U equals Q. So now, what do you guys want to call this equation? I can draw a cat. So I'm going to go back to my cat equation. Oh yeah, I probably could do a starfish. Okay. So now look at this cat equation. Does my cat equation now become Q equals partial U over partial T at constant volume dt? Yes? What happens to the other part? Right, constant volume goes to 0, right? So then may I write this as Q over dt equals partial U over partial T at a constant volume? That's a U, looks like a V. So far with me? What is this? We wrote it here. Number 2. It's CV, right? Chemistry people, you guys have seen this before, right? Not in Gen Chem? You will see it. So for monoatomic ideal gases, that means they only have one molecule, one kind of molecule. We can write CV as, oh, I bet you guys have seen this. Partial over partial T of 3½ NKT equal 3½ NK. Come on, you guys have seen this before. Diatomic ideal gases.
I'm only now taking Gen Chem.
CV will just be partial over partial T, 5½ NKT or 5½ NK. And for polyatomic gases, ideal gases,
It's okay.
3 NKT equals 3 NK. Or we can also rewrite this as 3½ NR, 5½ NR, or 3 NR. Drum roll. Done. Done, 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 done. So what about heat capacity at constant pressure? So I'm going to copy this picture over. Paste. Okay. These are called, making them smaller, moving them. These are called isotherms. What does the word isotherm mean? Same temperature. Isotherm. These both lines coming down are isotherms. However, they do differ in temperature with each other. Okay, so if you look at this picture, number 1 and number 2, points 1 and 2 are at the same volume. Points 3 and 4 are also at the same volume. And points 2 and 3 are at the same pressure. Now, what is the work done between points 1 and 2? How do we define work? P delta V? What's the work done between 1 and 2? Good. What's the work done between 2 and 3? P delta V? It is negative P delta V. And ideal gas says what? For 1 single mole of gas, for 1 mole of gas, may I rewrite this as negative R delta T? PV equals nRT. P delta V equals nR delta T. For 1 mole, that equation holds 2. We can also, so this was 1, 2. Now number 3, may I also write the delta U between 1 and 3 is the same as the delta U between 2 and 4. Isotherms? Good. Number 4, heat transferred at constant pressure. Can I rewrite this as Q equals Cp delta T from last week? Okay. Now going back to my first law, which was that. So for my first law, may I write this to be delta U, pick one. Do you want to do 1, 3 or 2, 4? 1, 3. May I rewrite Q as Cp delta T? May I rewrite this as negative R delta T? That equals that equals that equals that. From all the red ones that we have up there. May I also write delta U13 as CV delta T equals Cp delta T minus R delta T? There are delta T's on both sides. May I get rid of them? What am I left with? Okay, so the relationship between Cp and Cv in most chemistry textbooks will be written as, drum roll, for any number of moles of any gas.